actually learned about gases back in Chem 1, so this should not be a big new thing for you, right? So pressure, when we're talking about gases, is equal to the force, pounds per square inch, force per unit area. But in physics, because that's a yucky class, they use something called newtons. Not a fig newton, not a Newtonian or non-Newtonian fluid. It's a thing called a newton. So the SI unit for force is a newton per meter squared. What is a newton? A newton is the amount of force, the amount of energy, the amount of something necessary to take a kilogram weight and accelerate it at a certain number of meters per second squared, which is all a fancy way of saying that newtons involve kilograms, important to know, and they also involve meters. So just remember that. Think about meters and kilograms. Just remember that in the back of your head. And that's where they come up with this idea of a Pascal or a Pascal. And 1 unit of atmosphere, what we call 1 ATM, is equal to 101.3 kilopascals, or 101,325 pascals. Now, for you and I at sea level, that's about 14.7 psi. They're not going to use psi in chemistry, so let's not worry about it. On the AP exam, on your equation sheet, which you guys picked up on the first day, it should say have R values and all the gas laws you'll ever need. So that wouldn't be a bad thing to take out right now so that you know what's coming and what you need. Gas laws, they're never going to ask you to name them, but Boyle's law was all about if you hold temperature constant, what's the relationship between pressure and volume? And obviously you need to know that as pressure goes up, volume goes down. As pressure goes down, volume goes up. So they are inversely proportional. Charles' law, he's the one that held pressure constant, and he said that volume is proportional to temperature. In other words, higher temperature, higher volume. And Gay-Lussac, he's the one that held volume constant, and pressure was therefore related to temperature. You guys just need to know those. Dalton's law is very, very simple. It's actually on your equation sheet, and Dalton's law was just that if you add up all the partial pressures of gases, they equal the total pressure. So that's pretty simple. Avogadro's law, remember he's the guy with Avogadro's number? Well, he did actually his work with gases because they were much easier to take and mess around with and stuff back in the day. So Avogadro's law was very, very simple. The volume of a gas, if you keep the temperature and the pressure constant, the volume is directly proportional to the number of moles. And that's actually where we get the ideal gas law from. If you increase the number of moles, you increase the volume. This is going to be very, very important when it comes to working some problems. They'll say like the pressure doubled while volume and temperature were constant, or the volume doubled when you kept the pressure and the temperature constant. And all that is telling you is if one doubles, then you're like, oh, okay, now I know the number of moles of gas must have doubled as well. And the simple statement is, blow gas into a balloon and it gets bigger. The ideal gas law, PV equals nRT. You guys have used this a lot before. Notice this is on your equation sheet, so you might want to reference that and notice what it is. And R is just a constant, but it's 0.0821 liter atmospheres per Kelvin mole. One of the reasons I want to point this out to you is remember in AP, they hate to type things that look weird and give them a lot of trouble. So when they say K to the -1, moles to the -1, all they're saying is those things go in the denominator. Those things would be on the bottom. Because remember, anything to the -1 power really just means throw it on the bottom of a fraction. The other ones are very, very easy for you guys to know. P, V, N, and T. Just remember the temperature's got to be in Kelvin or else the whole thing doesn't work. You'll see STP, and STP is just something we made up. At 1 atmosphere and 0 degrees, we call that standard temperature and pressure. So if you were to plug that in, 0 degrees Celsius or 273 Kelvin and 1 atmosphere, you would get to 22.4 liters, which is probably what you were taught in Chem 1. There are a couple equations I need y'all to know. For a gas, you can rearrange the ideal gas law to solve for moles. And you can rearrange moles to put it in terms of density, and you can put it in terms of molar mass. So in this equation, D is equal to MP over RT. M is molar mass, right? So if you're given the molar mass, you can find the density of a gas, because density has to do with volume. Notice they took volume out. And notice also moles is missing. But the one I really want you to know is the one down there on the bottom. It's in blue. The molar mass of a gas is equal to dirty P. Dirty P, dirty P, dirty P, dirty P, dirty P, dirty P. Just say it, dirty P. The molar mass of a gas is equal to dirty P. And remember, go down a little bit on the P, and you'll remember to put it on the bottom. Dirty P. If you remember that, then you can find the answer to this problem. They'll tell you the pressure, they'll tell you the temperature, they'll tell you the density, and they'll say, find the molar mass. And the reason why this is helpful is because, anybody? Yeah, you in the back, yes. No, that's not it. Say, anybody else? Okay, yeah, that's more reasonable, yes. The correct answer there is you can find out the identity of the unknown gas. That's why that's helpful. We'll see you later. Bye.